Okay, I'm going to record now problem number 7. This is similar to number 1 that we just did, but again, I'm going to walk you through how you would use the summation of the forces in the x and the y direction and how you would write them up. You can probably figure this problem out without writing it, but again, I need to stress that you need to be in the habit of writing it all out. So this particular problem, we have a mass hanging from two ropes, one at 45 and one at a 30-degree angle. So let's start by drawing the free body. Draw your mass as a dot. So you've got a weight coming down here, which of course we know is equal to mass times the acceleration to gravity. You've got tension, do they call it 1 or 2? I don't know. So I'll just call this T2, and this one we will call T1. All right. So again, each of these needs to be broken into its components. So if this is 45 degrees here, then T2, I'll draw the triangle a little bigger. You have T2. The y component, of course, is going to be T2 sine of 45. And the x component is going to be T2 cosine of 45. And likewise over here for T1, here's our triangle, 30 degrees, T1. So our horizontal component will be T1 cosine of 30. The vertical will be T1 sine of 30. Okay. All right, so let's go through and sum our forces in the x and the y direction. First thing let's do is sum the forces in the x direction. We know they have to equal 0 because, again, there's no motion. Now this one is a little bit tricky because they tell you the maximum tension in the rope can be 1600 newtons. Now just a quick examination of these two tells you that if I look at it, I'm sorry, I'm going to start with the yeah, I'll start with the x direction. Anyway, a quick examination of these two tells me that this rope is going to carry more of a load vertically than this rope, obviously, because this one's at a steeper angle. So when I go and calculate for the tensions in each of these, I can guess that this rope is going to have a little more tension than that one. Well, if the maximum is 1600, then I can already pretty much assign T2 to be 1600. But let's go through and let's solve for the forces in the x direction. Our weight is only vertical, that has no horizontal components. I only have two horizontal components. T2 cosine of 45 and T1 cosine of 30, which of course is pointing to the left, so that's negative. And these equal 0 because there is no motion. So again, if I assume that T2 equals 1600, I can solve for T1. So we just do a little algebra rearranging and you end up with T1 equals T2 cosine of 45 divided by cosine of 30. Plug in 1600 here. And let's see what we get. I get 1306 newtons approximately. Okay, so this is less than the 1600, so that's good. So just out of curiosity, let's check and see what would have happened if I had assumed that T1 was the one that equaled 1600 newtons. Let's see what would happen. What would I get for T2 if I made that assumption? Coming back up to this equation here, I'm going to solve for T2. So T2 is T1 cosine of 30 divided by cosine of 45. Plug in my values here. Let's see what I get. $1959.6, and this is greater than 1600, so you could see this rope would have snapped already. So obviously, even if I had made that assumption, I would have figured out in the end that that didn't work because I can't go greater than 1600. But just common sense and life experience teaches us that this rope is going to carry more of a load than that one, so I can start off with my assumption of that one being 1600. Okay, so now I know what T1 and T2 equal, but ultimately I'm looking for mass, right? I forgot to write that down. Mass equals what? Okay, so if I know these two tensions, now I can solve for the value of my mass. And for that, I come and I look at sum of the forces in the y direction. And again, they're going to equal 0 because we have no vertical motion. So let's look here. I have three components to consider. I have the vertical component of T1 and T2, and then of course this one. So I'm going to have, sorry I can't have all this on the screen at the same time. So my forces in the vertical direction, I'm going to have T2 sine of 45 plus T1 sine of 30. Those are my components here. They're both pointing up, which is the positive direction. But now I'm going to have this weight pointed downward, so that's going to be minus mg. No motion, so I'm going to set it equal to 0. Now I know you could have immediately set these equal to mg because you know simple algebra, that's just intuitive. But be in the habit of setting it equal to 0 and solving for it now. The reason is because in the later sections, when you do have motion, the summation of the forces will not equal 0. They will equal mass times acceleration. So start this habit now when it's simple. So I know my T2, T1, I can go through and solve for mass. So let's do a little simple algebra here. I'm going to have T2 sine of 45 plus T1 sine of 30, all divided by G equals, let's substitute in here. We solved up here for T2, we said was 1600, of course. Sine of 45 plus T1, which we solved for 1306 times sine of 30, all divided by 9.8. Now I'm not showing the units here. Shame on me. Let's see what we get. 1600. And I end up with 182.1. And if you come back and look at the original problem here, it looks like we should be looking for two significant digits. So you should be going to about 180 kilograms. Although it looks like they actually want the answer reported to 3. I'm not sure why. Two significant digits should be what is required here. Let me look at this again. Did they ask for 3 significant digits? Nope, they asked for 2. Okay,